Hello everyone. Today we'll be solving the problem Zuma, right? So you can read the entire problem, try to understand. I'll just try to simplify as much as possible. I'll just summarize the problem and tell it in a simple way. So mainly, so the problem is to find the minimum number of operations that is required to transform an array into palindrome. So first thing, the two things we have to keep in mind. First thing is minimum number of operations. I'll just take this one, minimum number of operations required to transform an array into palindrome. So we have to transform minimum number of operations required to transform array into palindrome. I'll just take P for the palindrome. Minimum operations required to transform array into palindrome. This is first thing. And by splitting it to the minimum number of contiguous palindromic subsequences. Basically, we are splitting the array elements into contiguous palindromic subsequences. I'll just give subsequences or palindromic subsequences. These two things we have to keep in mind. One thing is we are the problem is mainly to find the minimum number of operations that is required to convert the array to the palindrome, and also how we can do that by splitting the minimum number of contiguous by splitting into minimum number of contiguous palindromic subsequences. So this is the question. So how let me tell you that. So what's the approach? So mainly, so as usual, we'll start with the first one is input handling, right? So first one is input handling as usual. Nothing but we are reading the data and split into lines for the further processing. First one. And second step is mainly while we write the code, you will get to know about the input handling. It is similar to most of the problems. It will be similar. The second one will be DP array initialization. We'll be making use of the 2D DP array where DP of this one L and R. We are making use of the 2D DP array, right? So where DP of LR, this represents the minimum number of palindromic subsequences needed to cover the subarray from index L to R. From index L to R. So this basically what it represents the minimum number of palindromic subsequences that is needed to cover the subarray from index L to index R. So this is what the second step is. We'll be making use of the 2D DP array. Third one is base case. Each single element is palindrome by itself. Suppose if we are considering A or B, it is palindrome by itself, right? So B is palindrome of B. So C is palindrome of D. So this is the base case. So each single element is palindrome of itself. So we will be setting this one DP of I, iterated value of the DP we have considered 2D DP array, right? DP of I'll consider this one, and we will set this one to 1. Why? I have explained this one. Each single element is a palindrome of itself. This is the third step. Fourth step, what we will do, we'll make use of the dynamic programming table fill. Nothing but for each possible subarray, the code determines if the current segment, nothing but from L to R, from index L to R, can be a part of palindrome and calculates the minimum splits that is required. So this is nothing but the DP array fill. While we write the code, you will get to know this is nothing but the DP table fill, right? I'll just give TR. The final step will be we have to output the result. Finally, what we are doing, DP of, just give me a second. Yeah, DP of 0 and n minus 1. So what is this? Basically, we are outputting the result, nothing but finally DP of 0 and n minus 1 will give the minimum number of palindromic subsequences that is required for the entire array. This will basically give the minimum number of palindromic subsequences that is required for the entire array, dp of 0 and minus 1. Again, I'm telling this is important thing. So dp of 0 and n minus 1, this one will give the minimum number of palindromic subsequences required for the entire array, nothing but the output. So let me delete this one entirely. Let's start writing the code. So initially we'll start with the, as usual, we'll be starting with the input handling, right? So we will begin with setting up the standard input reading process for Node.js, but we'll be making use of the JavaScript or the Node, right? So I'll just give process dot standard input dot resume. Next, process and set encoding to UTF-8. So this is first thing. Next, we'll initialize the variables for input handling. Nothing but, as usual, we'll set this one input string to empty array, and the second one is we will set the current line to 0. So next, we will make use of the event listener to accumulate the input data. I'll just give quickly process dot standard input. I'll just make use of on here data. Let me make use of input standard input as usual. So next, this will be input string. We will append this one to the input stdin. So this is one thing. Next thing, I'll just copy the same thing and make the necessary change. Just let me copy this one. So next step is we'll be making use of the event listener that processes input data once all the data is read. So usually if you have followed the previous problems, you'll be knowing these things. Input handling is always similar. Mostly similar, sorry. Yeah, this one here, what I'll do, sorry. This one I'll just remove plus here. This has to be input string, and also here instead of data, I'll just make this one to end, and I'll remove the input stdin. So to remove the white spaces, I'll just make use of the trim. Then to read the input line by line, I'll just give /n, and also finally we will map the string and remove the white spaces from the string. So this is same. I'll just give string dot, let me make use of trim to remove the white spaces, and I'll just make use of the underscore. So this is fine. Next, so here we have to call the main function here. So in the main function, we'll be writing the core logic, right? Or the main logic. So we have to call the main function over here. So we have not yet written the main function. We'll be writing the main function in the future. So I'll just leave the space here. So after writing the main function, I'll call the main function over here. So next step is we will write the function to read the next line of the input. How can we write that? I'll just give function read line return. So I'll just make use of input string of current line. We will increment this one, right? So this is nothing but the function to read the next line of the input. We have to read the individual lines, right? Every single input line by line. So that is the reason we'll be making use of this function. Next is we will be writing the main function. Means we will be writing the core logic or the main logic within this function. I'll just give function log. First, we will read the number of elements in the array. How can we read the number of elements in the array? I'll just give let n equals, I'll just make use of the read line. So here, so you can just give read line, right? So next, we will read the array elements and convert them to the numbers. First, we will read individual array elements and then we will convert them to the numbers. So how can we do? for individual array elements, we have to leave the space as well, right? For that one, to read, I'll just make use of this variable num. To read, I'll just make use of read line. For the space, I'll space between the numbers or the but for the space, I'll just make use of the split, and map of will convert this one to the number, right? The type number, sorry. This has to be of type number. And next step, what we'll do, we'll initialize the 2D array to store the element, to store the minimum operations needed for the subproblems. We are initializing the 2D array. We will, in this 2D array, we will store the minimum operations needed for the subproblems, right? I'll just give equals, let me make use of array from, right? This is fine. From array of n elements, I'll call. And finally, this will be array of n as well. We will fill this one with the positive infinity. So this is one thing. Next, as I have explained in the approach, we'll go with the base case. Means single element is always a palindrome by itself. I had explained that one, right? So for that one, I'll just make use of the for loop. How can we write this? For let I equals 0, I less than n. Let me increment the I. So here, this I'll just set as this is the 2D array, I'll just set this one to 1, dp of I. This set this one to 1. Hope this is clear till here, I hope. So next what we will do, the next step was in the approach, we have to fill the DP table, right? Again, for filling the DP table, I'll just make use of the for loop. Let me give for let r equals 1, r less than n, r s plus, I'm incrementing the r. So next, let's check if the last two elements are the same. For that one, always to check, we'll make use of the if condition, right? This is simple. If of r, this is equal to nums of r minus 1. Nothing but we are checking the last two elements are same, whether they are same or not. dp of r minus 1, r will set that one to 1. If they are same. Else what we will do? dp of s1 r, we will set this one to, right? So this is fine. Next, after this step, we have to iterate through the subarrays. To iterate through the subarrays, again we'll make use of the for loop. This is simple. For let r equals, for let l equals r minus 2, this will be l greater than or equal to 0. Finally, decrementing the l. So after iterating through the subarrays, we will check if the current element is equal to the last element of the subarray. So if it is equal, we'll be assigning that one to a dp of l plus 1 and r minus 1. So here this will be if nums of l, if this is equal to nums of r, then what we will do, we'll assign, and this is dp of l to r, this one to dp of next one, nothing but dp of l plus 1, and the final one, nothing but r minus 1. This is simple here, till here. So next, we will calculate the minimum operations needed by splitting the array. So we have to calculate the minimum operations that is needed by splitting the array. So for that one, we have to calculate the minimum operations, right? For that one, first we will make use of the for loop. Then for calculating the minimum operations, I'll be making use of the mat.min. So I'll just give for loop let k equals l, k less than r, K dp of L. This one I'll be making use of math.min. Sorry, this has to be math.min, not main. Of dp of, from the indices L to R, also dp of L K. Just give me a second. Did I miss anything here? So this bracket has to be here, right? Sorry. Okay. Plus dp of K plus 1, then R. This is fine. So the final step is we have to output the result for the whole array. For the whole array, we have to output the result, right? For printing, I'll just make use of the console log. I mean to display the result. So this will be dp of 0 and n minus 1. That's what I had explained in the approach. Final step. We have to, we are printing by making use of the console log, nothing but dp of 0, n minus 1. Nothing but we are outputting the result for the whole array. So after this, let me call here, our main function is completed. I'll just call the main function over here. So this is it. Next, what I'll do, I'll just come here and let's check for the input. The first one I'll consider. Sorry. Let me give here run. So unexpected token, starting this is this one, line number 43. Let's come here. What did I miss here? Just give me a second. Wait. So here, yeah, this has to be math.min, right? We're calculating the minimum. I had typed min, right? So that's fine. Let me hit the run again. So reference error, nums is not defined. Line number 31. I'll just come here. Nums, I have not defined nums anywhere. Just give here. This has to be nums, I think, not num. So yeah, now we are getting 1, right? The output that we are getting is 1 now, correctly. We are getting the output correct. So next, I'll just take this one input and let me check with the same. Let me come here. Let me paste over here. This time we are getting the 3. I hope this is correct. Yeah, we have to get the 3 itself, right? Next, let's check for the last input. This 7, this one we have to get output 2, right? Let's check the same thing. So sorry. So the output is 2. So this is working correctly. Just give me a second.
It's saying that
I'll just come here. Let me click on submit code. Problem B, right? So I'll just choose B, Zuma. Let me paste the code over here. Let me click on submit. So let's wait for some time. And
I fucking it can get up on me.
so yeah, you can see you can see here this got accepted, right? So the code works absolutely correct. So here I had made some mistake, I think. So here initialization, this one was a typo, and also here one more mistake I did somewhere. I forgot. Yeah, here min I had typed actually. Yeah, these two mistakes. That's fine. So this works absolutely correct. The code works absolutely correct. This is it. Thanks for watching, guys.